Okay, so let's pick up where we left off. So let's see. So right now we can do we can adjust our ball speed up or down, right? And when we hit start, it moves at that speed. Okay, and everybody, I think we were doing that for homework, right? To bring yours up to speed with that. That go okay for everybody?
Yep.
Okay, so the next thing we need to look at doing is, shut up. Keep hearing little chirps in my ear every 5 seconds I look down. All right, so as the next thing we need to look at doing is how do we make this guy move at a specific angle? Okay, because we're going to need things moving across the screen at different angles and that kind of stuff. So for starters, let's explore if we want this guy to move not just in that direction, but when we hit the start button, have it just move at a hard-coded angle up in the air. Okay? So let's go to our golf ball. And let's look at his physics. Let's see, is it under angle there? About motion. Okay, let's mess around under motion with angular velocity. Okay, so we're going to set this guy at, let's just do 50 for right now. Now, he's currently not moving. So what is angular velocity doing to him? Well, that's he's ultimately spinning, but why? He's trying to move at a certain angle, but can't, so he's just rotating back around. So he's hitting a wall, but he's still trying to force that. That make sense? Okay. As opposed to, let's see. Oh, they remove that behavior? Perfect. We could probably do this. Here, we'll make him go at 45 at a speed of 90. Okay, so he's now in launch position, right? We saw him move a little bit at the beginning, but he's in launch position. So as soon as we hit start, what's he doing? He's still moving across the screen, same way he was doing before. He's just kind of popping a wheelie. All right, so not what we were looking for. But he did hold that angle instead of continue to spin, correct? All right. We can accelerate towards a position. So maybe, let me just get a random position here. Well, here, we'll just make up a position. No, I want a random position. Let me just drag another golf ball out here. What's his position? 375, 195? Mm-hmm. Oh, sorry. And we're going to make this relative to the scene initially. Acceleration of 100. I'll go ahead and remove that second golf ball. Now he was moving in that direction, was he not? Slowly but surely he was inching his way over there.
Yeah, he's bouncing now.
Okay. So we were accelerating towards a certain position at a speed of 100. Now remember, acceleration is a cumulative effect. So what if I tell him to accelerate at a rate of 1? He is moving. Eventually, he'll start moving more quickly. Or actually, let's... no, I don't have to. He was moving. Just for the sake of argument, let's have him go at 10.
Didn't see that.
Okay, so he is moving, and he's slowly trying to inch his way over to this position. Actually, I might have this backwards. Let me try something. 195, 375. I don't think I did, though. No, I didn't. Okay, so we were asking him to try to get to this position over here, accelerating at a certain rate. But by the time he was accelerating, what happened? He ended up going off the screen. If we let him keep looping, he'll eventually meander his way over to this part of the screen. He should be coming back around here in a second. Actually, he is bouncing, isn't he? All right. So, also not what we're looking for, but we can accelerate to a point. We're already, let me just see the way we're making him move in our start button. In our start button, we are changing the ball speed, and then in our golf ball, are we constraining the attribute? Okay, so we're constraining his linear velocity on X to whatever the current ball speed is. So as that changes, this guy constantly constrains himself to whatever that number is. Okay, but that's only after we hit the start button. Now, we really want to get into a situation where this ball launches at this rate. Now, initially, we wanted to basically go at an angle right across the screen, not having gravity take any effect. Okay, but we want him to move in that direction. How do we pull that off? We can have him face in a certain angle. I already did that, right? So we can, this is kind of like if we go back into the golf ball, and right off the bat, we rotate to angle. And we say 45. And we can, here, we'll do it at a speed of 300, so it just gets there really quick. Okay, so he's kind of ready for a launch at this point. But we already saw that when we hit start, he just zips across the screen straight. But we want him to go up. How do I pull that off? Using only what we know how to do so far. Go ahead.
Could you constrain his Y attribute to the game turn ball speed as well?
Okay, well, that's not a bad idea. So let's go ahead and let's constrain.
You might even be able to
Chances are we're going to have to mess with these numbers a little bit, but let's see the behavior we get with this. So we're going to constrain this particular guy's motion, linear velocity on Y to that same game's global variable. Ball speed. Actually, is it current ball speed? Okay. Okay, so he's ready for launch. As soon as we hit start, kind of sort of did what we wanted, right? Okay. Now, we need to make that into a, let's try to hard code it, to a 30-degree angle. We're eventually gonna let them set the launch angle, right? But for right now, let's solve the problem of it. We need to make it be a 30-degree angle. So how do we take this, and instead of making this guy literally go up at the same rate as he's going across, up at the same rate he's going across, I'm drawing a little triangle here, how would we possibly do this? Trigonometry might be helpful. Okay, so we need to go draw a triangle, right? Okay. It's like, look, I did not go into computer science to do math. It's the Concordia way. Oh, wait. Oh, do I have? Can I? Boom. Oh man, this is going to be epic. Okay. Everybody shut up. All right, so let's just assume that, what's our baseball speed? 120? All right, so we have a ball speed of 120. So we'll be heading in this direction at 120. We ultimately want to go up here, but we want this angle right here to be 17 degrees. Does that make sense? So we need to decide how fast we need to move in this direction to accomplish a 17-degree angle. And really, I'll actually start this off by saying initially a 17-degree angle. Okay? So, how do we do that? How do I force this into a 17-degree angle? We know, let's put some given information in here. We know that we have a 90-degree angle here in this corner, right? And all these angles add up to what? 180. Okay, so we know that 180 minus this guy, minus 90. So we know these two add up to 90. Correct? Okay. So how are we going to, given this information, we need to plug in a value for this so that we get that. And watch this. This is going to be awesome. Can I do that? Yeah. See? My keynote prowess is epic. By the way, since I told you, how many of you started playing Hearthstone? None of you? What kind of computer science majors are you that you don't get addicted to video games? I didn't get to bed till like 1 in the morning last night because I made this like pact with myself that I would keep playing until I lost, and then I just went into savant mode. I won like 7 or 8 games in a row. All right, so here's our math problem. So what are we going to do? What are some suggestions? Now there's 2 levels of accuracy we're looking for here, as you keep this in mind while we're solving this problem. One level of accuracy is that we want our numbers. Ultimately, when we tell the user on the screen that your golf ball went X number of yards, well, not X, but you know, Y number of yards, your golf ball went Y number of yards. When we tell them that, we want that to be accurate, assuming we're hitting the ball in the vacuum, where there's no friction. Okay? Now, what's less important is that the visual is completely accurate. Does that make sense? If visually it looked like it went at 18.25 degree launch, okay, just because of the orientation of the screen, not the end of the world, right? We're probably not going to be getting up to the screen with a protractor, like, wait a minute. You guys all do that for Battlefield, right? Make sure the bullet mechanics are correct. Well, of course. You got to make sure you understand your setting before you start gaming, right? So visually, we want it to be close enough to fake them out, right? But numerically, we need it to be accurate, because the ultimate purpose of this is for somebody to be able to use this application, plug in a couple numbers and say, well, if my ball speed is this and my launch angle is this, I will hit the ball this far, assuming we have no error. Make sense? Then we can start throwing in some friction values for air, maybe give them, a generic friction value for air or something like that. Like average air has this friction, so given that, your ball may go this far in average air or something like that. The reality is, it's not that important because what we're trying to do for them is we're trying to give them an idea as to, ultimately the way this tool would be used is if I know that my ball speed is Z, gotta make sure my variables are in order. If I know my ball speed is Z, what loft driver should I get to help me produce a whatever angle launch in order to get the most distance? Does that make sense? So if I have a slow swing speed and my ball speed is 100, well, 1. Ball speed is 1. You just get the putter out, you swing hard. Okay. No, if my ball speed is 100, which is relatively slow ball speed, I'm going to want much more loft on my driver to get the ball up in the air and hopefully have it carry some short distance, but it'll be a long distance for me relative to a lower degree loft driver. Okay, that kind of makes sense. So the people who are going to be using our tool are people who are trying to sit there on the toilet doing math like, okay, I'm about to go shopping at the pro shop and I'm going to buy a new driver, and what should I get to help me hit the ball farther besides get a better swing? Right? Okay, so what do you suggest here? Go ahead.
You do tangent of 17 and multiply it by 100.
Okay, you want to take the tangent of this and multiply it by 120. Why?
Because tangent.
It's arc
Why arctan?
because you do tangent of x over 120, and then to get it to the other side, you do arctangent of 17.
Okay, what's tangent?
Opposite over
Opposite over adjacent. Okay, and you want to do arctan to get you what?
17. To get it,
You want this angle.
Yeah.
Right? Is this what we're ultimately trying to solve for?
no.
Don't we know that angle
Yeah,
already?
we know that angle.
We know this angle, and we can infer this angle by getting this angle.
Yes.
Mhm.
Okay, so you want to use arctan of what?
Of 17 equals x over 1.
Equals x over 120, where x is this guy. Right?
That's
Yeah, I don't think this is it either.
because it should, according
Go
to
ahead.
that,
So the 120 is the ball speed, right?
Correct.
So wouldn't the ball speed be going at the angle? So wouldn't it be the hypotenuse of the...
Well, but what we're trying to do here is, because of the way we're solving this currently, is we're trying to figure out what do we need to start moving on y,
Okay.
up. If we're moving this direction and we're moving this direction, what do we need to set those two at in order to hold
Okay.
this angle? Assuming that, when we actually do this, gravity is going to be pushing down on this, so it's not going to hit that. But initially, we don't have any gravity, so we're basically trying to set the y correctly so that we get to this point, ish. Get a better answer?
Then x is 180. 181.44486.
181. Okay, so you want to try to set this guy to 181, just for the sake of argument.
Sure.
Okay, so just for a quick test of this. $120 divided by 181. So we need to add an extra 66% onto the main screen. So 1.66. So we're going to change the attribute on y to whatever this guy is times 1.66. That should relatively simulate it based on your numbers. Because he wants this, you want x to be going at 180, 186, right? Or 182, whatever you said. 180 something. Okay, so we want this guy up here on the y. So maybe I should have called this y. It's y now. We want y to be going up, according to his math, he wants to be going up at 180 something. Okay, so that means that this number is 1.66 times this number. Ish. Right? All right, well, let's see what that looks like.
Yeah.
So we were going up a little quick.
Y value should be less than our X, or yeah, our Y value should be lower than our X value, shouldn't it?
Mm-hmm.
I would think so in this case. We can confirm that real quick. If we say, how about times 0.66? And we already knew it wasn't what? Actually, 0.66, if we wanted that to be a 17-degree angle, that may not have been that far off, really. It just didn't look very good.
What's the 1.66?
No, the 1.66 I don't think was right.
No.
But the 0.66 may not have actually been as wrong as it appeared because we were really talking about a pretty low angle. So we might actually have to visually have this scale so that a 17-degree launch looks more like a 42-degree launch or something like that visually. Have the math work out, but we like to see the ball go up in the air, not slight little pixel angle across the screen or something like that. So what if we do this by let's do 0.90, but yeah, ish. Yet, when we did it at the full speed,
Takes off like a bat.
oh, hold on, we're doing something. Am I updating the wrong one?
Oh, that's the right one.
We may have broken the world. Yeah, something's not right here.
If you saw the new Thor movie, it's all repairable.
Let's just hard code it to 120 real quick.
Don't spoil it for me.
Mm-hmm.
Okay, well that definitely looked better. So we need to hit. Okay, we're definitely in better math now. My guess is that when we started doing the math things in there, it screwed up our variable. So let's set it back to current ball speed. And my hope is it's fixed now. Yeah. Yeah, something when we started adding some additional stuff into that field, it zigged when it should have zagged. So I guess when you start messing with math in these fields, if you're going to change it, just clear it out. Make it completely empty and then start from scratch. So let's go ahead and let's set we'll constrain it to the current ball speed times 0.9. I'm going to say 0.9. I don't think it makes a difference, but whatever. Legit-ish, okay? Ish, yep. So we're probably going to want to, now let's see if we just make a small little change. Let's do 0.7.
We're getting there.
Yeah, it's looking pretty legit. Point 0.5. Okay. But without a doubt, I think we can say that his point is confirmed that definitely y should be less than x. Right? So we're back to our drawing board. Go ahead.
I think I figured out why it was. I think it's 27.9.
You think y is 27.9 for a 17-degree launch?
Yeah.
Okay. So, and we'll go back and do the math here in a second. So that means that, so 27.9 divided by 120, so it's 0.23, it's 23% of it. So that means for a 17-degree launch, hard-coded, we need to multiply this by 0.23.
Mm-hmm.
We'll end up doing the real math, but that looks pretty legit. Okay, what was your math?
Well, I figured that take the ratio of the missing angle, which is
This guy?
3,
Okay,
and you divide that by 120, you have a ratio.
so you figured out this guy first.
Yeah.
So let's go there. So you took 180 minus 90 minus 17 minus our desired angle, right? And you came up with what?
73.
73. Okay, so that means that we know, based on that, that our angle up here is actually 73.
Yeah.
Okay. Oh. I defy you. 72. Okay, then what? Let's get rid of this crap.
I took 73 and divided by 120 to get a ratio of 0.608.
73 divided by 120 to get 0.6 what?
0.83 repeating.
0608. That ish?
Yeah,
Okay.
and then I set that ratio to 17 over y.
Okay. So then you did this math. You said whatever this guy is, this 0.608333 is equal to 17 over y.
Yeah.
Okay. So then to solve for y, you did what?
Set the ratio.
We're making our little algorithm step by step.
Then I don't like explaining math, but you put the y, you multiply that against the ratio, so that you have 0.60833 times y
Equals 17. Okay. So 0.608333 y is equal to 17 because you multiply both sides by the y. That got rid of the y on the right, added a y to the left. So now we're looking at this math.
And then you take 17 divided by 0.608.
Okay. All right. So ultimately, those are our steps that we have to take in order to get this, right? Now that we know the steps, we've seen the work. Remember your math teachers, they all want to see your work. We know the work. Can't we then, if we know this is our launch angle, and we know that this is the ratio, can't we then just take our launch angle and divide it by the ratio? Isn't that what ultimately happens through these three steps?
Yeah.
Okay, so now since we planned out the steps, we can see how we can write the code to do this, right? All right, so how are we going to do this? We're going to take 180 because we know that this is a triangle. We're going to subtract from 180 our 90, which is always, 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 always going to be 90. Okay? So really what we're going to do is we're going to take 90 minus whatever our desired launch angle is. Okay? So 90 minus our desired launch angle. And so let's go ahead, since we're going to end up doing this anyways, let's go into our code. And let's go to the game. Let's go to attributes. And let's go ahead and add an attribute for launch angle. We're ultimately going to be creating a little thing to set it. But let's just go ahead and give us a current launch angle, right? So we're going to solve a pretty similar problem to what we had before. So we'll do an integer. For right now, we'll just have a single variable called launch angle. And we're going to set this guy to 17 initially, right? Okay. Oh, sorry. Then, so back here, we can replace that 17 with launch angle. Correct? And we don't even need to think about this 180 anymore because we know 180 minus 90 is 90. So really we're doing the math 90 minus launch angle. Correct? Which will get us that 73. Okay? So 90 minus launch angle gets us our 73 that we then want to divide by our ball speed. Correct? To get us what? This number. So 90 minus launch angle divided by ball speed gets us this number. Make sense? Okay, and what did we do with this number? We took that number, well, we took our desired launch angle and divided it by this number. Put some parentheses in here. Actually, let me just do that on another line. If you will let me do that, please. So we're going to say launch angle divided by, just so we don't lose our steps, all that crap. So that is y.
Yeah.
Okay. So we need to go and plug all that in, right? So we'll actually have to start off launch angle at 0, and then once we hit start, set it to 17. Otherwise, it's just going to start going up. Okay, so we want to go in and put some math in for our golf ball. We're going to constrain the y to launch angle divided by, so we're going to constrain it to our games launch angle divided by, you know what, just so we don't have to redo that math later on, let me just do something here real quick. I'm going to go to my game, and we're going to add, we have launch angle, I'm going to add another one. Called current launch angle. We're basically going to do the same setup we did for ball speed. So I'll start launch angle off at 0 just because, actually we could start off at whatever, 17. But current launch angle will be 0. All right, that way we'll do our math in terms of current launch angle, and then when we hit start for right now, we'll just set current launch angle equal to launch angle. Okay, so now back to our golf ball. So we are constraining y. Okay, and y is going to be constrained to current launch angle divided by all that crap. So we're going to say our games current launch angle divided by, open parenthesis, 90 minus, and this is also cur launch angle, and let's just do two parentheses here. 90 minus current launch angle divided by current ball speed. Close parenthesis. All right. Now, notice how we walked through all the math. We wrote out all the steps, and then we were able to fill in the blanks for our variables. Okay, that makes sense? That's why I was belaboring the point of him telling me each individual step, because it became easy then to plug in variables. Okay, so now we need to go and just update our start button real quick. So when we hit this, we'll also change our attribute. What attribute? Our game's current launch angle. And for right now, we'll just set it to our game's launch angle. So as of right now, the only way we can adjust launch angle is by going in and hard coding our game's launch angle to a new value. Okay, now we hit start. It's doing the math for us. And if we decide we want to have a higher launch angle, we'll go into our game, change launch angle to 22, hit play. Now we're launching higher. Change launch angle to 70. That's what happens when you pop it up. If you've ever golfed, that's a pop-up. There we go. There we go. You know, last night in my golf simulator league, we had a guy that kept doing that. Like he probably isn't that bad at golf, but chances are with the winter he hasn't swung a club in months. So yeah, he just kept popping up. He knocked out one of the lights. Didn't even hit the screen. You know, the screen is like 8 feet in front of you, or something. He didn't get a driver to the screen because it went straight up in the air and broke a light. It was funny. Okay, so this makes sense. All right, now. Let's put it back down to something within reason. We'll put it back down to 17 because we like that, right? Sure. I promise you 17 is kind of in the right range of ideal for most, let's just say, like adult golfers. Okay, so that looks pretty legit. But now, gravity should have an effect on this guy, should he not? Assuming gravity's E. All right. So how do we do that? Well, do we do this at the game or at the golf ball level? The answer is both. So within our golf ball, we have physics. So we have density, we have friction, we have bounciness, we have rotation, whether it's movable or not, collision shape, which we we'll probably actually make that a circle, so we have the most accurate point of when it actually hits the ground. Okay? Drag and angular drag. Its density is what's going to play into gravity. Okay? But we need to first turn on gravity. So we go to our game. Actually, it's a scene. Go to gravity. And we need to set up an amount of gravity on X. What's the force of gravity in real life?
9.8 meters.
9.8 meters per second.
Shouldn't we be doing it on Y?
Actually, you should. I was testing you. Well, you don't like our weird gravity in our game? Where everything just kind of pushes you sideways? That's what it's doing outside today. How many of you have been outside today? It's like horrible, isn't it? It's like not that cold, but you can if you stood outside for 10 minutes, you'd have like horrific wind burn. It's like really windy right now. Okay, so we're going to have a 9.8 units of gravity. So one thing we're going to have to start kind of look forward to here is what happens if we have, because we're ultimately going to want our distance in yards. Because that's what golfers like. We want to know how far we hit our golf ball in yards. Okay, well, right now we have gravity set at 9.8 what? We know it's 9.8 meters, but is that what this guy thinks? Possibly. So we don't know as of right now. So we're going to need to make sure that all of our numbers match up. So we're going to go ahead and hit play. And everything falls out of the sky. But if we react fast, not fast enough. Hold on. I don't suck that bad. Boom. There we go. Okay. It makes it, that adds the, just like golf, you might miss. Okay. So we do want our golf ball to be affected by gravity, right? But only after it takes off.
Right.
Now, is a golf ball in real life affected by gravity at all times? Sure. Mm-hmm. What keeps it from hitting the ground? The tee. So we're going to have to build a little tee. Okay, but before we do that, we need to make sure that our other things, our interface, does not fall from the sky. Okay? We can do that by changing these guys, their motion. I'm sorry, it's not motion. Is it physics? To not movable. Okay? So everything that we don't want to move, set him to not movable. right. Go ahead and save real quick. I just have a bad feeling.
Hey.
Okay, so they're not falling out of the sky. These are a golf ball.
Because it's constrained.
He is falling out of the sky, but we're constantly fighting against that by constraining his x and y, because when he falls out of the sky, what's actually changing? His linear velocities. Okay, it's not just saying fall out of the sky. It's saying, by the way, you have a force pushing on you at 9.8 something per something, and that force is a cumulative force, but every single time that you might start going 9.8, it pumps you back to 0 because we're constraining that attribute. That makes sense? Okay, so now we can hit start and our guy takes off, but we're still constraining that attribute. So we have an issue. After we hit start, do we want to constrain that attribute anymore? Well, maybe, but that attribute actually needs to now adjust. Does it not? Because we want our golf ball to, in fact, fall out of the sky. I mean, if we were a long drive contest, that golf ball's still flying. So we win, is what it comes down to. But we'd like our golf ball to actually fall out of the sky. So the very thing that we figured out to keep it in the air, to make it go at the right angle by constraining those two attributes, is now fighting gravity constantly. Does that make sense? How do we fix that?
Very carefully.
Using only what we know right now. It's like a puzzle. Isn't this stuff fun? Well, you almost have something you put on the App Store. Almost.
Yeah, you have to put a couple more colors on it.
Yeah, well, we almost have a working prototype. Suggestions?
Would the revenue go to offsetting all of our tuition?
Sure. I don't think it's going to make very much revenue.
All $2.
Lifetime. $2 a lifetime.
Yeah, it's 10 cents for everybody.
Yeah, but you're going to give Apple 70% or 30%. Apple takes 30%, we keep 70, and I guess we can put up on the Android store too, and then, double our profits to $4. All right. Suggestions?
Hey.
Go ahead.
Should we make an attribute that is gravity and include that in our launch angle of the golf ball?
Okay. So you want to create a attribute that is equivalent to gravity. Okay? So it's going to be some sort of accumulating force. Okay. I think so. How would you do that? Think MacGyver. Well, you can go and do all the physics stuff. I'll give you a hint. You can do this with MacGyver. Think about that over the weekend. For right now, I want to give you your next assignment. You're going to love the solution too. Okay, so anyways, for your homework, yeah, I put my subscription on World of Warcraft on hold because I'm playing Hearthstone so much. All right, so what are we talking about? Oh, so what we're going to do for our homework is you're going to bring your game up to this speed, but then you're also going to add an additional feature. That is, you want to add an interface for setting the angular velocity. I'm sorry, setting the launch angle. Setting the launch angle. So just so it's at the end of the video here, I'll go ahead and everybody relax. Let me go here. I'm going to go into, first of all, the game's attributes. So you can see what we currently have our games attribute set up to, and that's why we set it to have launch angle and current launch angle, just like we had ball speed and current ball speed. So you can have those guys work in conjunction, similarly to how you made your interface work now. Then I will show you over here on Keynote our formula. Make sense? All right. So I'll go ahead and stop the video.